All right, so now a deep dive into 4.5 and a deep dive into cellular respiration. There's more detail here than you're going to want to know. And yet, here we go. So, in glycolysis, okay, we talked about glycolysis last section, and we said at the end of glycolysis, you get paid, you achieve 2 ATP. And that is true. The net of the process is 2 ATP. But just like in business, you can't make money without spending money. Just like that, there's a similar thing. You can't make energy without spending energy. It's just a reality of the situation. And in glycolysis, you do end up having to do that. So we have you have two ATP are spent as like activation energy to get the reaction started. If you remember what activation energy, it's the amount of energy needed to start a chemical reaction. And then four molecules of ATP are produced, as well as two molecules of NADH. So here we have glucose. You add two ATP, right? Two ATP become a DP di. So two tris become two dis. And then you have four dies, and those four dies end up becoming four ATP. And so if I spend $2 and I get back $4, four minus two is plus two. And then two NADHs get their electrons reset, and then those two NADHs with the electrons that are reset are gained, and I can use those electrons later on. And the two halves of glucose are actually called pyruvic acid or pyruvate, and you'll see that during the like throughout this chapter. They'll refer to pyruvate as the two halves of the glucose because that's what it's called. I mean, that's its name. And there's actually names for the stuff in the middle, but we're not going to be responsible for that. So pyruvate is broken down before it gets to the Krebs cycle. On the way, once it enters into the mitochondria, pyruvate is broken down, and carbon dioxide is released, and NADH is released, and coenzyme A is attached. So carbon dioxide leaves. Remember, you have three carbons. If you get a carbon dioxide that leaves, you have three carbons. You lose one. Now you have two carbons. You get NAD plus becoming NADH, right? That gets redone. And then here you put a coenzyme A instead of the third carbon that was there. This is the steps that lead up to the Krebs cycle. So this would happen before the Krebs cycle even starts. All right. Let's not worry about all the intermediate steps here. Let's worry about what goes in and what comes out. All right, let's focus here on what goes in and what comes out. So, what goes in? NAD plus becomes NADH. So it's grabbing an electron. What else? Well, there's a CO2 here and a CO2 here. Remember, when we were back here, there was only two carbons and then a coenzyme A. You can't break down coenzyme A. It's not something for you to break down. So here you have a CO2. Here you have a CO2. They both break down. Oops, I didn't mean to switch it there. There we go. Here you have another NAD plus becoming NADH. So this is one, two, three. NAD plus is becoming NADHs. So that's three sets of high energy electrons. And then FAD2 plus and becoming FADH2. FAD2 plus is just like another Uber. Let's call it Lyft, I guess, right? If we're going to keep going with the analogy, it's like the lift of the system. So here we have an Uber and a Lyft carrying electrons. Okay. In that process, you've broken down the pyruvate. You save the coenzyme A. You've gotten a bunch of high energy electrons from what was left uh, of that coenzyme A, of that CO2 with those two carbons with the coenzyme A on it, and all of that is going to go to the next stage of cellular respiration, which is the electron transport chain. Now, some things to bear in mind, okay? NADH and FADH2 are made, and they're the electron carriers. The intermediate stuff with coenzyme A enters the Krebs cycle, and this intermediate's in the middle of that. But I'm not going to ask you of the name of this or the name of this or the name of this. Like I'm not interested. There is citric acid here. Some people call it the citric acid cycle because of it. It's interesting, but not exactly game breaking for you to know or not know that.